Hello, welcome to Unreal ArcViz webinar series number 3. Welcome. We are going to talk about lighting today. So, before we begin, a couple of questions. I hope if Chris, you can set the polls. Have you used UE4 before? Great to know if you're a beginner. And have you seen the previous webinar? Because I'm going to talk about, go over some things we've talked about before. And if you have, it'll just be a quick reminder. Otherwise, I'll explain a little bit more for those who weren't there. Great. So let's crack on. Today we are going to look at two scenes I've done. One in the interior like this one. So we've got an overcast sort of scenario with soft lighting, and I just need to blow by those. So yeah, soft lighting, soft shadows, and this kind of very easy to set up. And then we will look at the same scene lit by with artificial lighting, and then we have just here a range of spotlights, AEC lights, little Omni for that little lamp there with a lampshade, subsurface lampshade, and then we've got a couple of spots and some area lights for the back of the shelves, and then some big area lights that I put up, some big self-illuminating spheres that I've put up in the staircase. So we'll have a look at how I've set that up, and then just that scene that some of you might have seen already, which is a great example of a daylight exterior sunny day setup. So I'll take you through that, and then this exterior, same exterior but lit by night from photo references that I found on the internet, and it was really exciting to work like this. So I'll take you through that. Okay, so quickly, another question. Do you already know about deferred rendering? I talked about it last time, and it's a way to go into the comparison of V-Ray and Unreal. So if we come back with the polls for that, it'd be great, so that I know if you already know about this. But anyway, I'll carry on. Here we've just got typical V-Ray render, and we've got this lovely soft light happening, and this we all know about. So what this V-Ray is a forward rendering. So the camera shoots out a ray and sees what's happening when it hits geometry, and then renders the pixels, more or less, as far as I can sort of understand. That's my understanding of it. Maybe not completely scientifically based, but here what we're trying to do is understand a little bit how Unreal works. Okay, so this is showing the way this deferred rendering happens, again, as far as I understand, and this is showing how we effectively have the different renderers working on top of each other like layers. So where's my little diagram here? Oh, I've lost it. So yeah, so I'm just gonna move that one up here. So yeah, so here we've got, it's moving, it's layers of different renderers stacked on top of each other, contributing to the final pixel color. So that's what we've got in the end, is our rendered image, but made up of all these different things that we are controlling. So here we've got our outputs that we're fairly familiar with, like the Z depth and the ambient occlusion here, but there's many that work internally, and that's kind of a little bit beyond me. But it's really interesting to understand how this works, because when we set up the different components that make up our final pixel, it's useful to begin to think that way rather than the way we've used to working with V-Ray. So the skylight here is it takes up HDRIs and cube maps and everything. So I've put cube map here, especially because that's what I'm going to show you to work with very, very simply. So we've got the environment, the atmospheric. So we went over this last time. No need to go over it again. But the direct light, for those who don't know, is going to be the sunlight, and we've got some examples working with that, and the light mass, so where we have the dreaded build button and the build times that go through the roof. So we'll try and see some few tips how we can deal with that. And so basically this is the global illumination, the GI, the light bouncing around that Unreal calculates for us. Then we've got our reflection probes. Again, we spoke about that last time, and we've got different ways of generating reflections, and those are very quick and useful, but they're not very precise. So we've got screen space reflections and planar reflections to work with instead. So what complements lighting? So what we've got in parallel of lighting is the post-process, and so it's really not wouldn't be wise to talk about lighting without talking about post-process, because in Unreal they are both interlinked, and there is a sense they work together because they are part of the same package. Whereas lighting is in the traditional offline rendering workflow, the lighting happens in 3ds Max, rendered in V-Ray, and the post-process is done in Photoshop or After Effects. So we don't really want to go back to modify lighting after we've rendered and done the post-process in another package. So traditionally there's a cutoff between each of these, and we won't get much chance to revisit the lighting. Well, if we really have to, obviously, but we're going to make a few unhappy people. So this is different, and I'm going to explain a little bit what is for me essential in the post-process, which, as you can see here, it's HDRI tone mapping. So the reason why that is, first of all, I'd like to poll this question: how many people have you used V-Ray? Are you a V-Ray user, regardless of Unreal Engine? Because if you are, I'd like to address some concepts that we are familiar with, which are this stuff. It's sRGB, Gamma 2.2, linear workflow, color mapping, blah blah blah, exponential, Reinhardt, all this stuff. So you know, we're the ones who are familiar with the Gamma. This is that blue line is what happens inside the software, inside the computer. Everything is linear, but the response in this case, the response of this very, very old, now defunct monitor, the curve was more of this light blue one, the 2.2 curve. And that was integrated into the rendering, and then we've got ways to clip the highlights, which are exponential, and so on. We've got the Gamma 2.2 calibration with our texture maps, and it all gets very complicated. And on top of that, here we've got the environment colors that contribute to the pixel being handled by 3ds Max and then by V-Ray, and this button comes in as an option. So it's all very complicated, and it's all first to cater for a technology that is no more. So it works for sure. It's just a way to effectively lighten our shadows. But something has happened under the hood that I thought is worth mentioning because I didn't know about it until I found out through this tone mapper. What happened is that in the film industry, they obviously have the same problem, and they've been working on it. The Academy, I think this is the Oscar Academy, has been working on it, and they've come up with a standard so that people, I guess different studios, can communicate and exchange files, because since rarely one studio works on the same movie anymore these days, so they needed to get something that's going to work for everybody. So they came up with this, and it's already been a couple of years old, and from what I understand, it's been in Unreal Engine for a couple of years, but under the hood, and it's been enabled by default since version 4.15. So as usual, it's great, because a lot of the times when Epic do an update on Unreal Engine, it means that we have to do nothing. So this is why you really don't have to do anything. It all works without you doing anything. So however, I'm just going to explain to you what this is. Slope, toe, shoulder. I had no idea what that was when I saw it, and so what that is. That curve, that gamma curve, has become our S curve that we would probably use if we were doing color correction in Photoshop, especially to color, to change contrast and things like that. So that's what that does. The slope is that black line, the angle of that black line. The toe is that here, so how tangent to the horizontal it will be. And the shoulder is the opposite. The white clip and the black clip is the things we're very familiar if you've used levels in Photoshop. And that's it. So that's really, really simple. The effect of that is that the tone mapping has changed between version 4.15 and this is V-Ray. When you were to increase the intensity of a spotlight to unreasonable levels, very, very high, which is kind of extending the range and challenging the tone mapper. But this is what happens in reality, obviously the sunlight being the brightest of all things. And light behaves in a certain way and so on. So here it's this blue colored spot increased to unreasonable high intensities, just became even more blue. It's just tending a little bit to the purple there, but really just became massively more blue. Here, on the other hand, in Unreal Engine, when this is increased very, very high, you'll notice that the color changes over to white and becomes completely burnt out. But as opposed to all the problems we had using linear in 3ds Max while rendering, the burnout spot is very tight here, and there's a beautiful gradient going from white to the blue, and obviously here also due to the square fall off. So what I've done is just taking a picture of this LED here, and you can see that what happens in the photo is that at the brightest point that has actually gone white as well, completely burnt out, and then the rest is beautifully kind of gradated and depicted. So Unreal is now able to represent this effect much more accurately. So the other thing to mention though is that I didn't see this with my eyes. With my eyes I saw something not quite like that, but that was still red. So interesting. But this looks more photographic. Other thing to mention in the post-process volume is definitely the white balance. This was the original shot without the white balance. applied, and I just lowered the temperature here, which now enabled me to have a lot more of a play with the cool, because this obviously being covered in all wood, it's very warm in color. And then I added this, well, the reference had this concrete floor, which was rather cool. So it allowed me to turn that down and bring the coolness back out into the floor, whereas here everything's warm and it looks a bit sort of like a sepia colored tinted. LUT, I'm going to refer you back to the documentation for that, because it's explained very well. I didn't actually use it in that scene, so I can't show you the demonstration, but maybe I'll see if I can do a speed up demo and put that on Intercept it in here. Right, so let's see. Let's crack on, because we've got much to go through. So here, the layers, the LUT, yes. The vignette is simple and easy. It's always great to add the vignette, I think. So you just see that here, those edges of the scene look very bright, and they sort of don't really tell much of a story, or so. With the vignette, it enables to tone them down and to bring the focus back onto, you know, the sort of the focus area of you've chose, usually away from the edges, I guess. But so that's really simple and easy and quick to do. And the exposure, I need to show you this in the interface. So let me just. Right, so I'll show you about the exposure in the interface here. Okay, let's give ourselves a little bit of room. So it's a little bit of complicated, because there's all these things: min brightness, max brightness, blah blah blah, exposure bias, and all these things, which I'm going to go into in a minute. But the first thing I'd like to point out to you is that if you click on this lit button and you go down to exposure, you have the ability to fix at log 0. Okay, and I have the taken the habit to set my intensity of my skylight at this setting of 0 here, so that I have some way of knowing where we are, because what happens with this exposure from the post-process setting is that, you know, it's going to, so obviously it doesn't work here because I'm on 0 here, but it's the exposure here is going to vary up and down. So you might set the exposure and you think it's right when you're kind of here. Let me just show you. Oh, so I bring back to automatic. So you see, so we were kind of all right here. So I've set the exposure bias to -1.2. And then here is kind of just a bit too dark, really. So here we want to be up here, really. Okay, so nearly at 0. So that becomes a little bit annoying. And then also what I do is this speed up and speed down. I whack it up to, you know, whatever maximum, to so that you don't have to wait for ages, so that you know exactly what's going on. So here it's over bright. So either you make the whole thing so that the exposure is not going to change, and that sort of works. Usually, that's what we're used to when we do fly-throughs in V-Ray, because the exposure doesn't normally change unless we tell it to. Or what is a little bit more complicated here is to use this brightness mix and a min and max. So in this case, they recommend sort of have the min brightness near 0. So you know, we can have it at what the recommended level is, and I guess that will probably work in most places. But in this particular interior, it needs to be quite high, you know. So I set it at 1.2 here, so it will never go brighter than that, even if we're some very, very dark places. So that's what is good to understand. I think this maximum brightness needs to be changed much less often. It doesn't really, so that's kind of to deal with the same affair, but with our darkest spots. So how dark the darkest will go, but it doesn't seem to, to need tweaking much. Okay. So that's for the exposure, but I think it's quite important to point this out. I went for ages without knowing about this feature here, exposure fixed at log 0. So it's been, I think Kula in the forums recommended to put them both at the same value. So say if you're both at 1, that kind of works all right. But if we put them all sort of at another value, then we need to change the exposure bias to get back to something acceptable, and then it's all very complicated and a bit contorted, and then might be unpredictable. So I just try to keep it simple like this. Work. So I'll say it one last time, fixed at log 0, and then once it's more or less within range, I just go back to my post-process volume and just tweak the exposure on and up, and work with this min and max brightness to adjust it. But at least I'm not way off. Okay, so I hope that makes sense. So maybe I'll just leave it at this for now, and let's go back to our next slide. So this is kind of the slide I put together. So let's have this little walkthrough of how I go from basically how I set up that scene altogether, and I show you from the start how to create a really, really simple, easy cube map. Because reason why HDRs are very obviously superb, great, but I wonder whether Unreal deals with them absolutely in a perfect way. I've had a bit of strange things happen that weren't that predictable. And this is a really simple way and really easy to have a very flat color, like an overcast day, to light your scene. And it's extremely predictable lighting from all sides, and gives us a nice environment color to work for. It's a little bit like having the color for the environment in the environment slot in Max or in V-Ray. And so that's really easy. It's the sort of basic GI setup. And so I show you the walkthrough, and then I must admit, I've kind of put this sequence of events after I've done the video. So some of it doesn't quite match, but it makes more sense as a good workflow. So I'll keep that. I'll keep referring to that in the video. So let's just crack on. So this is me playing the video. There's like the old PowerPoint problem, but I thought we haven't got this problem anymore of the video not playing. Right, nothing that a restart won't fix. So here we go. I'm creating in Photoshop this cube map. So feel free to fire up Photoshop and go along with me on this. This is me doing it, but I've sped it up, so it might be a bit quicker than you. But while your Photoshop's starting up, if you're in front of your computer, feel free to do it, because then you'll have a cube map ready to go to use in your own project as soon as this webinar is finished. So I just create a square image, 1024 pixels or 256 will do actually. I don't know why I did it so big. And I just resize it, scale it 600 times, 600%. So we want this image that we have in this, no, I haven't got that, an image that comes in this web page exactly, which is telling you how to create cube maps. So this is obviously in order to output them from Max when back in the days when you needed cube maps. So here what you do is you get this these numbers from the web page, and then you save it as DDS from Photoshop. This is how to create cube map, and you make sure this is on cube map. No need to bother about maps. This works like this. And then save it as DDS. And so basically here I've taken you into the interface, and I'm building up just bringing some geometry into a new level that I've created to show you how I set up that cube map into the skylight. So then I'm just bringing a skylight, make that bringing that. So I've just imported the cube map that we've just made, all there. Yep, all good. And I've just stuck it in there in the image slot of the skylight. So now I've set up my skylight. Now I'm looking at the light maps. So just making sure that it's all this right resolution, because as you know, when they come in, those squares are really big. So I make them really tight so that they're red in color. So you can press on your keyboard Alt 0. Alt and 0 give you this light map density view, and you can access it through this button as well, of course. So once we've got the light maps, I'll just pause here because I'm just going to the light map settings. So light mask portals, I add them afterwards because I forgot. So we've got our light mask settings, and these are the ones I use. So I turn the environmental color to black, but do try it with white as well, because it adds to some of the dark areas. So it's very interesting. And the settings I use are 0.75 and 0.75 for indirect lighting smoothness and static level scale, and then number of indirect lighting bounces to 12 and lighting quality on 4. You can bump that up to 10, 20 if you need for the final render, but when I'm working, I either leave it on 1 or 4. Okay, and so here I've put it onto, you might not have seen because I've was going too quickly, but here I turn my ambient occlusion off with the post-processor volume, and I've set my exposure on 0, and I've got my skylight. So just quickly here, while we're rendering, I thought I would just show you for those of you who don't know it exists, this is the swarm agent that Epic provide, which is the back burner, which enables you to render on lots of different machines. But also, it's when Unreal renders the light mass, it throws it out of UE4 into the swarm agent. So that's why while this is building lighting, you can still carry on working and use the interface, which is brilliant. So this is all handled by a separate program called Swarm Agent, and the network rendering works very, very well. It's really easy, and once it's set up, it's great. So, but what I am wanting to show you now is a way that when this comes by default, so let's just take you through the steps. You go into here, and most of the time you will see that show developer menu. So how do you get to here? You go on your system tray here, and you see that little S icon. You double click on it, and you get this swarm agent. And then when you go into the settings, you see that the show developer menu is set on false. So you set that on true, okay, like I've done here. And then you get your developer settings tab. And you will probably see that your local jobs default processor count is not set on the number of processors you have in your machine. I've got 8 cores into this laptop, and it was set on 6. So if that's the case, I've got 20% of my power which is not being used. So you just set this on 8, and you've just immediately gained 20% power. Therefore, 20% more time. So that's just a little quick tip that I'll just remind you of when we talk about the rendering time. But yeah, basically, so you can see that my CPU level here has gone very high. So I keep, so here I've forgotten the light mass portals. So I quickly add them, no big deal. But I do recommend you use them because I've noticed that the quality of the light calculation is much nicer, much better with them, and possibly quicker as well. And then when that's done, I carry on the so here the reflection probes. You see how important it is that back wall was really completely washed out before I moved it like this, and then I moved it, and that sort of corrected that problem. So here I haven't, this is just a default standard, you know, super material. There's nothing to it, just one image on the diffuse color. So there was something wrong with the reflection, but just to highlight the importance of the reflection probe. So here I've just come to the end, and I just backtrack a little bit to just show you when I've rendered. The rendering time for this room was 29 seconds to on sort of low quality or preview, and then the final one that I've got in here only took 5 minutes on production and 4 here. So it's really, you know, pretty satisfactory kind of lighting calculation and precision for such a small render time. So yeah, so that's my walk through here, and I'm going to go through some of the settings again just to make sure you that's all. So let's just go through the light mass just to make sure we are clear on that. So light mass, we go to world settings, and these are the values that I use. So here it wasn't even on 12.3, it was on 12, but yeah, when you set that to white, it helps as well those dark areas. So that's great. It helps with where the skylight doesn't get too. And yeah, so that's it for the light mass. Pretty simple. What you really want to do is untick compress light maps here. You really don't want to add some JPEG artifacts to your lighting, balanced lighting calculations. So light mass settings, light maps. So again, you press Alt 0 on your keyboard, and so you can see that here I've set them really, the grid is really small. I went possibly completely overboard because it's a very small room, and I wanted to see if it made a difference, but to be honest, it only took 5 minutes to render, so it's not a problem. You can see how it comes in by default. This grid is very large. So maybe not that small, but it needs to be, the way I like to describe it, the grid needs to be as small as or at least smaller than the smallest item that you're going to have in the scene, here being the especially the feet of chairs and things like that. So there's a bit of LOD here on there, but it's that's how this is very important to give you the smooth shadows, and also it massively increases your render times. So here it's not a problem, as I said, because it was only 5 minutes, but if you have a large scene and these light mass light map resolution are too high, then you really need to kind of bring them down to a level that is going to be more coarser. But I think, you know, the lighting quality in Unreal so far is great, so it probably could afford to be a bit more optimized than this on this scene, but so far so good. Okay, so carry on, light maps. So build time issues. Obviously we've got very high render times on some scenes. So here you probably already know this, but you know, I work on preview when I just put in I've got my light, and I want to see my skylight, and I just want to see the general level of lighting in the room. You know, how to set this intensity. And I'm probably going to have a lot of iterations, so you know, I work on preview, and then I put this down onto 1. Okay, and these are the only 2 settings that I tweak to change to work quickly and to iterate the lighting calculation, the lighting quality here and the lighting quality here. Obviously, if your scene's taking far too long to render and you can't handle it, then you're going to have to change your light map density, bring that down, and so as I told you, also swarm. So, but you get to swarm by, if you can't see it in your tray, in your system tray here, you need to set off a render. So you need to set off a render. I'm not going to do it now, but then your swarm will appear in here, and then you can do these mends I showed you. So obviously then with Swarm you can add machines. I'm not going to go into it now, but it's a bit complicated. It took me quite a long time to sort out to understand how it worked, but it does work. Okay, so carry on. Yeah, just also before a final, you've got to lighting info, lighting static mesh info, and you get this little window. And lighting build info, and here there's nothing, so, but you do have a look in here. It's a list that looks a bit like this, and you can order it by the time it took to calculate the lighting, and you will see that it's some of the ones at the top, sometimes some come out way higher than the others, so you can, it's a very quick and easy way to debug some items that really will need optimizing and looking at. So that's top tip here, to use this lighting info, lighting status mesh info, and look at the build times for each mesh. Okay, let's go back to the PowerPoints. Right, so now I think I've given you enough theory. Let's look at the scenes. So I just basically took you through, in fact, let me try and do it straight into, no, let's do it in the preset ones because it will be much easier. So here I've just started with the scene completely dark, and I've just turned the lights on one by one. So this is a kind of a good screenshot of the final lighting calculation with effectively the GI, which we can see here, which is sort of turned down really low. But what we have here is effectively the resulting calculation from the skylight, but with the bounce light turned off or very low here. So the shadow areas are very dark, but we see that we've got a really nice contact shadows and a really nice soft lighting coming from the diffuse sort of background color. So that's my skylight. That's the sort of the settings with my cube map in it, and then here set to sort of nearly 15. So that's with the global illumination turned back on basically. So we've got a really simple, just one light. And then I've added these spotlights here, and I'll go in the spotlights in a minute, but here what's interesting is that I've turned off my fixed exposure, and so now I've added this directional light, which is a skylight. So the intensity here is on 25, and I've given it a little warmth in the color. But you can see that as I turn my intensity way up, sort of nearly, to 80 and now to 1,500, the tone mapping really reacts very, very well. So this is where, after all this theory, we've got our nice sort of overcast day lighting, and then we can add a sharp light that comes from, maybe that's sort of sun's just poking through the clouds. And here there's more a kind of Mediterranean sun, hard sun coming in, and here's more of a kind of science fiction divine look, sort of God rays. Somebody's just seen inspiration. This is effectively, this is the kind of technique I used to light this scene, and it was actually that divine sort of light setup, high contrast, and there was a lot of work here done by the tone mapper to put everything in range, but it really is something we can use to create the level of contrast and emotional sort of message that we want to carry through. Right, so moving on, interior at night. So that's the shot here. So like I said, we've got spotlights in here. So let me just fire up the interface, and the project. I need the same project, and I will open the one by night. Okay, so it's just open straight away. No, so I get all confused as to what is what. And here everything's off, so that's great. Okay, so what we will do, I'm just going to show you using this thing. Or let me just have a quick. Yes, so you see, classic mistake. I had this exposure fixed at 0 from the previous, from having this level open, and now I've got this level, and I forgot. So I was like, oh, what's going on? So here it's a bit confusing, but so at this level, I've got 4 lights on the ceiling here. So, and they are AEC lights. So just to speak a little bit about these spotlights. They, the way the AEC worked for me is that I had to have this attenuation radius completely out. Normally it sort of comes, the outer cone angle, because obviously if you've got your cone like this, your AEC is going to want to display information up here, but the cone is going to block it out. So you need to have your cone angle really way out. Okay, and the AEC I've just put in here, so that's really straightforward. You just import it and straight in here, and so all these lights I've set on movable, so they don't get calculated into the shadow. And I don't know why my second frame is gone here, but anyway, the lights in the staircase are these spheres, which are just what I call area lights, but really what they are is with a material with a self-illuminated emissive color, with something called, called it emissive power, which I can change in here. So that's set on 10. And the mesh themselves must have the use emissive photostatic lighting ticked in order to be used as a area light. So same thing for these rectangles of light at the back here. So this is great because it's totally baked in, and so you can have as many as you want, and it will have absolutely nil effect on the performance of your scene. So you can have a limited amount of lights here. So obviously they're not dynamic. So here, this spotlight, what I've done, so if I just put these values back, you can see that it's quite a gamey, harsh shadow we've got here because of the spotlight. There's a nice fall off here on the edge because of the cone angle being, so in the inner cone angle, keep that to 0, well, if you want to, but that gives you a nice, you know, really nice fall off here for that. And then the outer cone angle was whatever that was. And so just for the shadow, what I do to soften the shadow is I lower the shadow resolution scale here. Okay, so just slightly. I'm not sure even if that's made for that, but that's the effect that it has. But then you see that the problem that we then have is light leaking through the shelf because our shadow bias is too high. So I just need to lower the shadow bias so that it effectively is going to be smaller than the size of this shelf. The problem that we will have is that if it gets too small, we'll have some self-shadowing. So we really don't want that. So it's this sort of very fine line between those two problems. But yeah, the resolution scale is nice to sort of soften the shadows a little bit. Okay, so that's for those lights. And then these ones, yeah, I'm not quite sure. Sometimes these come on, these stop casting a shadow, and then they come back on, see, like that. So I think it's some kind of LOD in the lights, but I haven't quite figured that out. Maybe it's because it's some optimizing within the interface. Okay, and then finally this Omni here is casting a light through this lampshade. So that's quite that was really easy to work to make this lampshade glow. And what's nice is that it's not casting a shadow. So when if I set up, I don't have this sort of the streaks of the lampshade on the wall because of this submaterial, this subsurface material. So that's works really well. Okay, great. So let's move on because time clock is ticking. So I've shown you, so I just show you the build up quickly of these lights. So that's the IES. IES naturally close to the wall have a really nice effect. That's the downlighters. That's the Omni by itself, and that's the spotlights together. And then if we build the scene back up, you see that it's very much like this sort of compositing again. We just sort of add all these lights on top of each other. And then we can even work with the global illumination as if we had a render pass just for that with this in the post-process volume. And so you really see how the post-process volume really becomes part of the lighting here, where we've got our indirect lighting intensity set low and then higher to 1. So we've got complete control over that after the lighting's been rendered, and then that's those spotlights we looked at. Okay, great. So now moving on to the exterior scene. So great thing about this one, there's no GI. It's super to work this way. There's no render, no GI. It's all animated, all the leaves, all the grass, everything. So I'm just going to take you through this walkthrough quickly because we're running out of time. But here, Effect Worlds is turned off for the skylight. So we've got really the base scene, nothing, just a reflection here. And then the skylight is added with this HDR. So it gives us a nice blue undertone, and you see that the detail, obviously, because there's not been any lighting calculation perform, the resulting lighting is very flat. But because this is going to be the color of my shadows, this is kind of what I'm looking for, a flat lit shadow. It comes from a little bit what I've learned in painting and drawing, where the shadow area is left without much detail and leaves a little bit more to the imagination, but it does have a tint. So that looks correct as a base, and you will see hopefully the success of that for later on. So here I'm building up the layers again. So if I flick between the two, you'll see that there's no change in my rendering of the scene because I've added the sky. So the fog was already taken, well, that sky was already taken into account by the skylight having its HDR. So here I'm building up the sky background, and then I'm adding the fog over the rest of the scene, right? So it's very much like we're working with a compositing package. And then I've added this dome blueprint, effectively, which is this material with a sky on it, which projects it as a dome sphere and animates it, makes it rotate at speeds that you want. So that's great. That adds a little bit of life and animation in the sky. And then, so you see that when I turn on the directional light of the sun, and that's made with a warm color on purpose, it really contrasts and it gives quite a good render of the whole thing in the end. So so that's again a very simple setup and very effective, and the skylight does a great job of just illuminating our shadow areas, and I guess we could even add a bit of ambient occlusion here to that I've probably turned off. I'll work with that a little bit more to get those contact shadows here working. But generally, because it's an outdoor scene, the sunlight will have an enormous effect. So just moving on for that, the night scene. So here, again, I just sort of build that up because it was very theatrical, great fun to work with again. So here I've just sort of added a little bit of faked bounce light from the ceiling. This has got some uplighters in the corners here, uplighting the ceiling, and this the white ceiling, which is giving a nice soft warm light to the interior of the house. So I tried to replicate that just with spotlights, so I didn't have to calculate any baking, saying that I probably could have just put a light mass importance volume just around the house and calculate the baking, the light bouncing just for the interior. But I didn't do that this time, focused on the outside, and here I've got some downlighters here from the edges, just flooding a little bit the edges of the house with these kind of very soft transition to complete darkness here. And then, these floodlights onto the trees. They were put on top of the roof of the house and just projected light out onto the trees, and they've got this kind of warm color here that I actually turned off these square fall off for these, so they're quite uniform and they've changed the fall off manually. And then these back ones that were sort of more in cool color, contrasting with the blue, with the warm for the rest. And then final, I couldn't help it to add the new the new volumetric fog, which begins to really makes us think, wow, the level of realism that we can achieve using Unreal Engine today is quite impressive, I think. So that looked great. that was great fun to play with. And why don't I just show you quickly how to rebuild this in the Okay, so this is we've got our skylight. Yeah, that's just a blue color. That's just giving a base. You know, again, this sort of just a base flat light over our shadow areas. And then, so just these two inside. So you see those downlighters here. Where are they? Just go perspective onto these downlighters here, and so that's what's going on in there. And then we've got our perimeter lights. So again, nothing too fancy, you know, that intensity there. So, you know, what's lovely here is that we can the way I've worked this is that you've got the folders, so I can just sort of turn them on and off this way. So if I just deselect them, so that's a great way to work. And then I just select them like that and just sort of click on the interface. And if I hide them, if I press G, then I can play with them completely. You know, or you can make a blueprint, and but this is incredibly interactive, right? So that's for the perimeter, and then the floodlight on the roof. I just turn those on, and then again, you know, there are only 3 there, but I can just play with them like this. And here I turned off the inverse squared. Yeah, so that's why this intensity is set on 20. Normally it would be much higher if I had the squared fall off. And then finally there's on the slope. And then the exponential height fog again is just super, because it's one of these things that really, there's nothing to do. All you need to do is just click that enable volumetric flow of fog. And here I've just changed the albedo color, brought it down a notch, and yeah, put the intensity quite high. And but yeah, it's fantastic thing to play with, this toy. So just to reiterate, the performance on this scene is really not great, and but you know, it gives us a nice image to stick at the end of the PowerPoint. So there you go. And if you want to know more, please do check my website. There's some new courses to be released very soon about lighting, how to get different lighting scenarios. So check out on the website and get in touch if you need to know more. So I'll hand back to Chris for now, and any questions, far away.